Alright, today we are talking about solving right triangles. Okay, when you hear that solving right triangles, it means we're finding any unknown measurements, whether it be angle measures or side lengths. So whatever you don't know, that's what we're trying to solve for here. Okay? Now, inverse trig functions. Okay? If you remember, solving this type of an equation, 2x equals 4, what do? You divide by 2, divide by 2. X equals 2, right? Well, we divided by 2 because that is an inverse operation of multiplication. Alright? It undoes it. It gets rid of it. Okay? Or like x plus 6 equals 14. Alright? You subtract 6 from both sides. Okay, again, why do we subtract? Because we're getting rid of the addition here. We're using the inverse operation. Same thing applies to tangent, sine, and cosine. Alright, to be able to solve for A here, alright, to find the measure of angle A, we have to get rid of tangent. So we use the tangent inverse, which is the little -1. Alright, so write either the inverse tangent of x or the tangent inverse. Alright, and if you look on your calculators, the sine, cosine, and tangent button right above it, and you can't see it real well on this, sine inverse, sine to the -1, cosine to the -1, tangent to the -1. Should be right above those buttons there. Or if you have to go into your menu to find sine, cosine, tangent, sine inverse, cosine inverse, and tangent inverse would be in there as well. Alright? So, we use these inverse functions to solve for the angle measures. Alright? Alright, first one here. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. Alright, so here's angle A. So again, you always look at, this is the angle we're looking at, we're trying to solve for angle A. Now, where are the sides in relation to that angle? 16 is opposite, 20 is adjacent. So which trig function uses opposite and adjacent? We're using tangent. So the tangent of angle A equals opposite over adjacent. Alright? The tangent of angle A equals 16 over 20. Alright, I'm going to rewrite it here for a second. Alright, now, we are solving for angle A, which means we have to get rid of tangent here. So we are going to take the tangent inverse of this side, and what you do on one side of the equation, you have to do on the other side. So we're going to take the tangent inverse of this side. Alright, the tangent inverse of the tangent of A, we're left with the measure of angle A. The measure of angle A equals the tangent inverse of 16/20ths. Okay? Or we could simplify that to 4/5. So the measure of angle A equals the tangent inverse of 4/5. Alright? So plugging that into your calculator. Okay? We're taking the second tangent inverse of 4/5. Okay? So there are my keystrokes. Second tangent, 4 divided by 5, and then close my parenthesis. Open parenthesis, I have to have close parenthesis. And again, your calculator should be in degree mode. Alright, and we find out that that angle measure is 38.7 degrees, because it was nearest tenth. Nearest tenth of a degree, so 38.7 degrees. Alright? Alright, let angle A and angle B be acute angles in two right triangles. Use a calculator to approximate the measures of the angles to the nearest tenth of a degree. Alright, so we want to find this to the nearest tenth of a degree. So the sine of angle A equals 0.76. So we want to solve for A, and we want to get rid of sine. So we take the sine inverse of that, and we have to take the sine inverse of this side. The sine inverse of the sine of angle A, those two cancel each other out. We're left with the measure of angle A equals the sine inverse of 0.76. Alright, so on your handy dandy calculator, alright, I'm going to clear this out. We have second sine of 0.76. Well, a little sensitive here. Alright, 0.76. Alright, and enter. So the angle is 49.5 degrees. So it's about, measure of angle A is about 49.5 degrees. cosine of angle B equals 0.17. All right, solving for angle B. So cosine of angle B equals 0.17. So we want to take the cosine inverse of this side, take the cosine inverse of this side. And that's again 0.17. Cosine inverse of the cosine of B, we're left with the measure of angle B, equals the cosine inverse of 0.17. Alright, so the measure of angle B is about, alright, so now the cosine inverse of 0.17. Second cosine 0.17. Okay, and hit enter. 80.2 degrees. Alright, and again, this set of two right triangles, alright, so there are two different triangles, so these don't have to add up to anything special, alright, because there were two separate triangles. Alright, so, questions with that one? Alright, another one. Solve the right triangle. Round decimal answers to the nearest tenth. So, solve the right triangle, meaning find any and all unknown measurements. So right now, what don't we know? We know the measure of angle. We do not know the measure of angle B. We do not know the length of BC, and we do not know the length of AC. Okay, so two sides and an angle measure. And anytime you see this, solve the right triangle, there will be three unknowns. Whether it's one angle and two side lengths, or if it's one side length and two angle measures. There's always three things you got to solve for. All right. So looking at this, we have an angle. We obviously can find the measure of angle B real easily. All right, 23 and angle B have to add up to equal 90 degrees. So 90 minus 23 is 67 degrees. Okay, so the measure of angle B is 67. Great, now we need these two sides, and I'll call them X and Y respectively. So which trig solving for side lengths, we can't use the Pythagorean theorem because we only have one side length. We can't use special right triangles because that's not 30, 60, 90, and it's not 45, 45, 90. So the only thing we have then is the trig functions. So here's our angle. Here, we'll start with X. It is opposite, and we have the hypotenuse. All right, which trig function uses opposite and hypotenuse? That would be sine. So the sine of 23 equals opposite over hypotenuse. So now, we know the angle measure, we're not using the inverse trig function. Alright, we are solving for X. So multiply by 40, multiply by 40. So 40 times the sine of 23 equals X. Alright, so on your handy dandy calculator, maybe. Alright, I'll do it on my calculator here. 40 times the sine of 23. Alright, 15.6. X is about 15.6 feet. Okay? And X is length BC, so 15.6 feet. Okay? Now, we want to find Y. Okay, and we're still going to use this same angle here. Alright, here's the angle. Here's Y, that is adjacent. And we're still using the hypotenuse. So cosine of 23 equals the adjacent over the hypotenuse. So again, multiplying by 40. So 40 times the cosine of 23 equals, those cancel, we're left with Y. So Y is about, and it will be feet, alright, 40 times the cosine of 23. So 40 times cosine of 23, 36.8. 36.8 feet. Alright, solving the right triangle, three measurements. Okay? Alright, we're building a ramp for a model train. Alright? You want the track to incline from the first level up to the second level 4 inches higher. 4 inches higher over the span of 96 inches. Alright, is the angle of elevation less than 3 degrees? Is X less than 3 degrees? Okay, we're answering that question here. So, we have The angle here is what we're looking for. Here's the side, so that is opposite and adjacent. So which trig function are we using? That is tangent. So the tangent of angle x equals opposite over adjacent. Okay, solving for x, we got to get rid of tangent. So now we are using the tangent inverse. The tangent inverse of this side as well. Tangent inverse of the tangent of x. X is gone, so we're left with the measure of angle x equals the tangent inverse of 4/96. So the measure of angle x is about, alright, on our handy dandy calculator, second tangent, 4 divided by 96, 2.4 degrees. Alright, so is the angle of elevation less than 30 degrees? Yes, it is. Alright, so when you are trying to find the angle measure, you're using the inverse trig function. When you are trying to find the side lengths, and you know the angle measure, you're not using the inverse trig function. Alright? Know the difference. The only time you're using the inverse trig functions will be when you're trying to find that angle measure. Okay? Alright, here's two problems I would like you to try for tomorrow, and I'll answer questions in class about these two problems. Alright? Thanks a lot.